Hi there, Mr. Sutton bringing you another lesson on trigonometric identities. In this one, we're going to be looking at identities of angle, sum, and difference, and applying those different formulas to do some different things with trig functions. Let's take a look at these sum and difference formulas now. There's 6 of them, and it's going to look like a whole lot of stuff to memorize, but you will start to notice patterns. So for sine of a sum here, you've got sine of the first angle times the cosine of the second angle, plus cosine of the first, sine of the second. And sine of a difference is exactly the same stuff, only you're subtracting the two terms. Cosine works kind of the same way in terms of the plus and the minus being different in the different equations. So cosine of a sum, you're doing cos minus sine. Cosine of a difference is the exact opposite, cos plus sine. So really, if you can just memorize one of these, you know that the subtraction one is just going to be changing the sign. So that at least cuts down on how many things you have to memorize. Now, it is possible to quickly derive the tangent identity by just doing sine of a sum over cosine of a sum. We're not going to do that, but you could do it, and you would end up with a fraction that looks like this. So we've got tan of the one angle plus tan of the other over 1 minus tan. Tan of a difference, again, it's the same stuff, but the signs have all been reversed. You might notice with sine and tangent, at least if you're looking at the numerator here, the signage inside the parentheses matches what you have in the formula, at least again in the numerator, whereas cosine's the odd one out. Let's use those formulas now to simplify some expressions. Now, a very common problem type is to start with the second half of the formula and then work backwards to the original left side of the formula. Here, before we do any of that, though, let's turn all this into degrees, because I don't work so well in radians. So this is really going to be 135, 90, 135, and 90. Now we have to figure out which formula we're looking at the right half of. We have sine cosine minus cosine sine. So that is going to be the sine of a difference. So we have to use one of those formulas. And what this will allow us to do, if we look at this as this kind of stuff, we can say, oh, well, A is just 135, alpha is just 135. This B in here, beta, is really just 90. Now I can combine those angles that are dispersed all over the place here in one neat little parentheses. So I can rewrite all of this as just sine of 135 minus 90. That's really just the sine of 45. And if you do have special angles, then you should go ahead and simplify them. So this would end up being root 2 over 2. Here's another one. Pause the video and simplify this one as far as you can. So here we've got cosine plus sine. So this is one of those cosine ones. I always remember when you have the double trig functions in each term, it's a cosine. And cosine's always the opposite of what it looks like. So this plus really means we're doing cosine of 100 minus 15, which is just the cosine of 85 degrees. Now, 85 is not a special angle, so we can actually stop right there. Pause the video and try this next one now. So you might recognize this as the tan of a sum. This is really just the tan of 4x plus 3x, which is the tan of 7x. And that's as simplified as that's going to get. Let's change gears now to a new problem type. Here they're asking us to find the exact value of cosine of 15 degrees. And you might be saying, well, wait, that's not fair. 15 is not one of my special angles. So what we're going to do here, our strategy, we're going to express this angle, or try to at least, as the sum or difference of two special angles. And then we can use one of our sum or difference identities. So there's a lot of ways of expressing 15. I tend to use the smallest angles I possibly can, so I can express 15 as 45 minus 30, but there are certainly other ways to do this. And the cosine of a difference now, that's going to be cosine of 45 times cosine of 30 plus, because there's a minus in here, plus sine of those two angles multiplied together. So that's my cosine difference formula in action. Now I just have to go through and actually simplify all these values that we can get because they're real special angles. So cosine of 45, that's root 2 over 2. Cosine of 30, root 3 over 2. This is where knowing those special angles is so helpful. Sine of 45 is root 2 over 2, and sine of 30 is 1/2. So when we actually multiply this out, we got to do a little PEMDAS here. We've got root 6 over 4 plus root 2 over 4. Since we have the same denominator, we can actually move both of those in together in the numerator for a final answer of radical 6 plus radical 2 all over 4. Now you might be saying, wow, does this mean I can now simplify any angle that they throw at me? No, you can't. You can't make any angle out of some combination of adding and subtracting 30, 45, and 60. Even if you throw the quadrantal angles in there, you can't do that. But you can simplify now anything, it turns out, that is a multiple of 15. Anything that's a multiple of 15, there's some combination of special angles that you can turn it into. Pause the video now and try this one on your own. Hopefully you decided to put this in degrees first. It's tough enough even remembering the special angles, let alone trying to figure out what they add up to when it's in radians. So we can convert this into 165 degrees. That's 180 divided by 12 is 15 times 11, 165. And what can we split 165 up into? Again, remember we can use addition or subtraction. There's lots of options, I'm sure, but I'm going to use 120 plus 45. If you had a better idea, then feel free to use it. So for this, I need the sine sum formula, which is sine cosine plus cosine sine. So I'm going to have sine of 120 times cosine of 45 plus cosine of 120 times sine of 45. Same as the last problem now. Just go through and simplify these. Well, it's almost the same as the last problem. You might notice here that we have some angles that are not within the first quadrant. This 120, it might be helpful to get a reference angle for this and rewrite this with reference angles so that we get our signage correct. So 120, the reference angle for that is just 180 minus 120, or 60. Rewriting this with 60 now, we have to pay attention to what quadrant we're in. Sine is positive in the second quadrant, so we can rewrite this as positive sine of 60. Cosine's negative in quadrant 2, to the left of the y-axis, so this will be a negative cosine of 60 over here. And that will make a difference, of course, in the final answer. All right, let's go through term by term. Sine of 60, that's going to be root 3 over 2. Cosine of 45, root 2 over 2. Negative cosine of 60, that's going to be negative 1/2. And then sine of 45 is again root 2 over 2. So we've got root 6 over 4 minus root 2 over 4, or radical 6 minus radical 2, all over 4. Now you might be saying, wait a sec, that looks kind of familiar. Well, if you look at our answer on the very last slide, we had root 6 plus radical 2 over 4. Because you're limited to doing multiples of 15 that you can actually use this trick on, there's not a whole lot of different problems out there. And since they all involve these three special values with sine and cosine, 1/2, radical 2 over 2, radical 3 over 2, you're always going to end up with some combination of root 6s, root 2s, and 4s. You just have to make sure the order and the sign are correct. That's it for sum and difference identities. We'll actually be using these to derive a few more identities in the next lesson. Until then, this is Mr. Sutton signing off.